Okay, Trig, this is the last little bit of the notes for section 4.2. We are going to, let's do this. Let's skip example 6. We'll move on down to what this thing represents, and I'm going to talk about that in terms of your unit circle. So make sure you have your pink sheet, your unit circle out. We're also going to do a calculator bit here in just a minute. So make sure he is ready to go. But here is what this thing means. It talks about like the period of a function, okay? And like the period is basically talking about like the cycle of the function. So like a sine function, a cosine function, there's a certain point where the values of them begin to repeat, okay? So like on your unit circle, we've talked about coterminal angles before. So I'm just going to pick on like 30 degrees, right? If I go and I have an angle that starts here and it rotates up that much, that is 30 degrees, okay? But if I instead rotate around and go this much, that would be like 360 plus 30 degrees, so like 390 degrees. Those two things are coterminal angles. And what's going to happen is that they're going to land in the same spot. So if I'm trying to find like the sine value of 390, it's going to be the same as the sine value for 30 degrees. Sine is the y-coordinate, so the sine value is going to be 1/2. Cosine is the x-coordinate, so he will be square root of 3 over 2. So I could say that cosine of 390 will be the same value as cosine of 30, which is square root of 3 over 2. So what happens is that cosine and sine make a full circle at 2 pi or 360 degrees, and then their values start to repeat, right? Like 30 and 390, they would end up being the same value. So sine and cosine, their period is 2 pi because after that, or after 360 degrees, those values start to repeat and start over again, which makes it really nice because let's say we are trying to find like sine of, I don't know, like 800 degrees or something. All we need to do is keep subtracting 360 and keep subtracting 360 and do whatever until we get a small enough angle that we can find it on the unit circle, right? Because the unit circle only goes between 0 and 360. So we just keep subtracting and find new coterminal angles so that he will end up being small enough that we can find sine and cosine. Now, cosecant, since he is the reciprocal of sine, and secant, since he's the reciprocal of cosine, those guys are going to have a period of 2 pi as well, right? Like those values will begin to repeat every 360 degrees, or 2 pi. Now, tangent and cotangent are a little bit different. They're the only two out of the 6 that have a different period other than 2 pi. So let's just pick on tangent. Tangent's period is pi. Let me show you why that is. Okay, let me erase all my junk here. You guys have tangent labeled on your unit circle, and let's just pick on, like, I don't know. Let's pick on, well, let's just look at these. Tangent of 0, 0. Tangent of 30 is square root of 3 over 3. Tangent of 45 is 1. Then we have the square root of 3. Then we have undefined, okay? Now, over here, when we get to these guys over here, when we continue going around the unit circle, it's negative square root of 3. That's not quite the same as positive square root of 3. It's just the opposite, right? Like all of these values are going to end up being the negatives of what the other ones are until we get to here. Tangent of 180 is 0, just like this one was. Tangent of 210 is the same as tangent of 30. Tangent of 225 is the same as tangent of 45. Tangent of 240, that's the same as this guy. And tangent of 270 is undefined again, which is the same thing here. So it's like these guys that are here are the same as these values here, okay? And so what happens there is that tangent, starting at 0 degrees, he has the same value of 180. So he starts repeating after 180 degrees, right? Like this top half of the circle is exactly the same as this bottom half of the circle in that order for tangent, right? Like I could even look at 11 pi over 6. 11 pi over 6, his tangent is negative square root of 3 over 3. He will be the same thing as 5 pi over 6, negative square root of 3 over 3. So after 180 degrees, he's going to begin to repeat, right? His values repeat. And 180 is another way of saying just pi units, okay? And since cotangent goes with tangent, that's how he repeats. So it makes the unit circle a little bit more digestible, I guess you could say, because, those values are just repeating. Like a lot of these same values that you see in this first quadrant are the same as what's over here. It's just the signs are different, like one's positive, one's negative, etc. Okay, and we'll talk more about that going forward. But a lot of those values are just repeating, like square root of 2 over 2 and square root of 2 over 2. Well, this is negative square root of 2 over 2, comma square root of 2 over 2. So like those are exactly identical from one another. It's just that this guy has a negative on him, right? So, a lot of those same values are repeating, okay? So let's go to, that just has to do with the period, like how long before those values start to repeat, okay? So tangent, let me just think about this, like, let's say I have 20 degrees and I'm trying to find tangent of 20 degrees. That will be the same value as tangent of 200 degrees because there's a 180 degree difference between them, okay? So in that sense, you can almost just subtract 180 each time to try to figure out what, and that doesn't mean that they're coterminal angles, like 20 and 200 are not coterminal angles because they are not at the same spot on the unit circle. It's just that their tangent values will be exactly the same, okay? So there's that. All right, let's move on and let's talk about example 7. And it says, given sine of pi over 12 is this big junk right here. Okay, do not look at this. Don't even look at that right now. Don't look at this. Cross it off. Don't even think about it right now. Don't cross it off, but don't think about that, how ugly that is. Sine of pi over 12 is what they're looking at, okay? Now, pi over 12 is going to be like, I don't know, 15 degrees or something. Pi over 6 is a 30-degree angle. I don't know if you see that right here on your unit circle. So pi over 12 is half of that, so it will be a 15-degree angle right here, okay? You didn't need to know that, but I'm just showing you, like, that's how that works, okay? So that's not on our unit circle just because we don't have increments of 15 labeled on our unit circle. Otherwise, our unit circle would be even worse, but that, is a thing. All right, they want us, given that information, they want us to find sine of 49 pi over 12. Okay, let's check out 49 over 12, regardless of the pi. 49 divided by 12, I know that 48 divided by 12 is 4, right? So this would be 4 and 1/12 pi, right? That's what 49 over 12 is, okay? Now I know that sine is going to repeat every 2 pi. So to find like a coterminal angle, I'm going to subtract 2 pi. If I do that, I get 2 and a 12th pi, right? If I subtract another 2 pi, I get just 1/12 pi, right? Or they write it as pi over 12. That's the same thing as 1/12 pi. So what we've done here is by subtracting 2 pi, which is the period of sine, that's how often sine starts to repeat. The period is 2 pi, the period is 2 pi. We can say that the sine value of 49 pi over 12 will be the same as the sine value of just pi over 12, right? Well, I know that the sine value of pi over 12 is this ugly thing that I don't really even care about. If I'm trying to find sine of 49 pi over 12, he will be exactly what that is, the square root of 6 minus the square root of 2 over 4, whatever the heck that is. This is going to be the answer just because these two are coterminal angles and, they're in increments of 2 pi, which is what the sine's period is, okay? So I can just add and subtract 2 pi to find me values that are nice and then use that to say that these two values are going to be the same, okay? All right, a couple more things. This one is talking about, here we go. This is talking about, like, how these functions work. Let's pick on, let's pick on pi over 6, which is, let's pick on pi over 3, which is 60 degrees, okay? 60 degrees, or pi over 3, he is, I gotta think, 1/2, comma, square root of 3 over 2. I gotta check that, make sure. Yeah, 1/2, comma, square root of 3 over 2 on your unit circle. Right there he is. Okay, so if I have him labeled correctly, that's where he is. All right, now, what's going to happen is 60 degrees is from here to here. If I go negative 60 degrees, negative 60, what's going to happen is, like, think about this coordinate point in terms of, like, how much you go over and how much you go up to get to that point. Like, I've gone over 1/2 and I've gone up the square root of 3 over 2. Well, if I want to go negative 60 degrees, I'm going down just that same amount, but I'm going to the right 1/2, and this time I'm going down square root of 3 over 2. So my coordinate point is only going to change and make the y coordinate negative, because the y value is negative in the fourth quadrant, right? Like, he's gone over the same amount, he's gone up, but now he's going down instead, and he'll be negative that value, okay? So the deal here is that when I have a value of t, okay, and I change it to be negative t, right? Like, I changed 60 to be negative 60. 60 degrees became negative 60 degrees. What's going to happen is the 1/2 stayed exactly the same. 1/2 didn't change. Going to change. All right, so maybe this is worth writing down. It's kind of summarized over here as well, but that might be kind of worth writing down over there, just so that you can see that. I'm going to erase some stuff over here. Maybe I didn't want to erase that. I'm going to erase this stuff right here. Okay, so let's say now instead we pick on this spot over here, okay, which is 60, like, if this is 60, then this guy would be 60, right? So this, I don't know if I want to say that. No, I don't want to say that. I don't want to say that. I'm not going to get into that yet, because that's another loaded thing. But anyway, so here's how this works. There you go. Cosine's going to stay the same, sine's going to become negative when you change them and make them negative angles, okay? Now, that works even if I'm in the second quadrant, right? Like, if I have, like, a 135 degree angle, right? And in a 135 degree angle, this is going to be negative and this is going to be positive, right? So for the 135 degree angle, if I do the same spot but down instead, this guy is going to stay, right? The cosine value, the x coordinate stays, but the y coordinate, when it was sine, he becomes negative sine, right? So if this guy's positive, now he becomes negative. So it's the same thing if you're doing with the second and fourth quadrant, right? Like 135 degrees would be here. This would be negative 135 degrees, right? The y coordinate is just going to change and be a different sign, okay? And that's how he works on the unit circle. So, blah, 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 all that stuff. Okay. Same thing with since cosecant and sine go together, that guy will switch to negative, but since secant and cosine go together, he will stay positive. These two stay positive, these guys become negative. Now tangent, since tangent is special and he is sine over cosine, if you do tangent of normal t and tangent of negative t, he will switch sign. He will become negative because sine became negative. Cotangent's the same way. If you do cotangent of normal t and cotangent of negative t, he will switch sign, okay? All right, so because of those properties, sine is an odd function, cosine is an even function. Cosecant is an odd function, secant is an even function. These two out of here are the only ones that are even functions, because they are the only ones that stay exactly the same when you plug a negative in. Otherwise, all of the rest of them are going to be odd functions, because when you make, like, sine of 45 degrees is square root of 2 over 2, but sine of negative 45 degrees, he will become negative square root of 2 over 2, right? Like, this value changes to negative. Cosine is not that way. Cosine of 45 degrees is square root of 2 over 2, but cosine of negative 45 degrees is also square root of 2 over 2. Like, he doesn't change at all. This guy's the one that is going to change. Sign is going to change. And the fact that he changes, and if he changes sign, like positive, negative, he is going to be an odd function. The even ones stay even. They stay the same value. The odd ones are the ones that switch. Okay. All right. I just confused you a lot. Whatever. Okay. What are we doing? Oh, there we go. Okay. I don't know what's happening. Okay. Example 8. Use the properties of the trig functions to simplify. Okay. Here's the deal. All right. Cosine of negative. We just said that if we take cosine of a negative angle, it's the same thing as cosine of the positive angle, right? He's not going to change, right? So, and we have that up here if you want to, like, just, yeah, these two things are equal to each other. Cosine of t and cosine of negative t, those things are equal to each other. Oh, I guess they have it over here. Cosine of negative t is equal to cosine of positive t. Those two don't change sign. So I can just insert cosine of t in for that to swap them out. And then I have 4 cosine of t plus cosine of t. And this has like an imaginary 1 in front of it. And this is just like adding 4x plus 1x kind of, right? That would be 5 cosine t's. Okay? All right. Part B, they're wanting you to use properties to simplify. Okay. Ugh, I don't want to do part B. Skip part B because we haven't talked about this part yet and I don't want to get to that. Well, actually we kind of have. I'll talk you through it and then, you know, whatever. All right, so tangent of negative 3t. If I'm taking tangent of a negative angle, the whole thing is going to become negative, right? So the value switches and he becomes negative, not like cosine. Cosine, if you take a negative, he pops back out as positive. Tangent is the opposite way. Okay, this guy is talking about pi. If I add 180 degrees onto whatever my angle is, it's going to stay the same as what it was before because that's the period of tangent. So tangent of 3t plus pi is the same thing as tangent of 3t. Okay, so now I have this guy minus another one of those, which is negative 2 tangent of 3t. And I've thoroughly confused you, and this is really confusing, but, you know, whatever. Now let's get to the easy part. The easy part is example 9. Use a calculator to approximate the function cosine of 2 pi over 7. We don't have one of those on our unit circle because our unit circle doesn't go in increments of 7s, but when you do this, you need to make sure your calculator is in radian mode because 2 pi over 7 is in radians. Okay, so if you have a fancy calculator, like one of the graphing calculators, and you need to remember how to switch it, you go to the mode button, which is right below the, no, not the y equals button. It's right below the second button, which is blue. This guy is a blue button. And mode is right below that. And then you go down as soon as you get to the mode screen, and you switch it from radians to degrees, okay? Or no, excuse me, degrees to radians. You want to be in radian mode. And then all you have to do is cosine, like you type in cosine, and you can open parentheses. You can do 2 pi divided by 7, and you type it in, and I don't know what you get. Hold on, I need to get a calculator. I have calculator number 8, by the way, on my desk at school, and I don't know who it belongs to. It's pink, if somebody is wondering where theirs is. I want to say it's Matthew's. Did I steal Matthew's calculator the other day? I don't remember. Matthew, if you're missing a calculator, I have it. 2 pi over 7. Nope. Nope. Oh, shoot. Mode. Mode is over here, not at the bottom. It's right next to the second button, not below the second button. Okay, I'm going to be in radian form. Okay, and you should get 0.6235. They want it 4 decimal places. By the way, if you are switching to from radians to degrees and you want to get back to the regular screen, hit the second button and hit the mode button. Second mode, because it says quit right above mode, and it will take you back to the normal screen. Okay, so if you're wondering how to do that. B says cosecant of 0.92. They do not say that, they don't put a degree symbol here, so this is a radian, okay? It's kind of an icky radian because normally we want to put radians with a pi in there, but this is just the decimal version of a radian. We don't have a cosecant button on our calculator though, but cosecant is the opposite of sine. So what we do is we do 1 over sine of 0.92, okay? So on your calculator, we need to make sure we're still in radian mode. We're going to do 1 divided by Like this is exactly what I'm putting on my calculator. Oh, it does the little dash symbol. It does one of these. 1 divided by, and I'm going to type in sine. It opens up a parentheses, 0.92. And, whoop, and I get 1.2569. That's what you should get if you are in radian mode. So cosecant, secant, cotangent, we don't have a button like that on our calculator, so we do 1 over, and that gives us what we want. So there you go. Whew. What a mess. There's way a lot of stuff to teach you off of this unit circle. Sorry. Okay, work on homework so that we can go over questions on Monday and get done with section 4.2 and move on. Okay?